Alright, let's see this. What do we have today? Looks like a herd. Okay, so put marbles in bag. You have k bags. You're given 0 index integer array weights, where weights of I is the ith is the weight of the ith marble. Okay, and you're given k. You're given integer k. Divide the marbles into k bags according to the following rules. No bag is empty. The ith marble and the jth marble are in. If the ith marble and jth marble are in the bag, then all marbles with an index between them should also be in the same bag. Okay, so all the marbles between I and J are inclusive or in the same bag. The bag consists of all the marbles with an index from I to J inclusive, and the cost of the bag is the weights of I plus the weights of J. Okay, so the bags only cost the end weights. So if there's a bunch of weights in between, it doesn't really matter. The score after distributing the marbles is the sum of the cost of all the bags. Return the difference between the maximum and the minimum scores among marble distributions. Alright, so if there's 2 bags, then the maximum bag would probably be 351. So the distribution, so 351. Okay, maximum minimum scores among marble distributions. So the maximum score should be 351, which should be 9. No, sorry, it's the maximum would be 51. So that's 10. Distribution 1, 351 results in the minimum score of. Okay, so you have to sum up all the scores of every bag, and that counts as one distribution. Okay, so if you have the bags be 1 and 351, that gives a score of 2 for this bag and a score of 4 for that bag. That's the minimum, so that's 6 for that distribution. And if you did 1, 3, that gives a score of 4, and 5, 1, that gives a score of 6, so that gives 4 plus 6, which is 10, which is the maximum sum. And then the difference between the 10 and the 6 is 4. Ooh boy. Okay. And it could be one element as the bag. And the cost would be twice that element. Cost would be twice the weight. The weight would be quite whatever. I'll approach this. We have K bags. What if you went through Can you do this linearly? Probably not, I want to say. Okay, so if you were to try to get the maximum, what you would probably do, I guess the maximum and minimum are very much the same, so if you can solve the maximum, you should be able to solve the minimum. So for any element within your weights, you can either choose to keep that element as the single element of an interval, so you have the cost is double that weight, or you extend it. And if you try to extend it, then then you would get a later, you get that weight plus some later weight, and you skip every weight between them. Huh. Okay, I think this is, I called it before as dynamic programming, and I've been wrong before, but I think this feels like dynamic programming. You should be able to go through each element and have the the best number of weights, the best number of bags to that element. Okay, so it's definitely something I should be better at. Let's say you had a best array, and the best array will be it'll keep track of let's do the maximum. So maximum score using using up to k bags in current pass, and the best will be 0 times, I want to say k plus 1. No, it's n plus 1, I think. And this should be actually, I'm going to collapse it. I'm going to say the best will be for up, so I'll keep track of the index. I'm going to collapse it. I'm going to say this is just going to be up to k bags, so k plus 1, and say n is the length of the weights. And for each index, I'm going to keep track for index in range of n. So what I'm thinking of is, let's say I have a best, and let's say k is 2, and the best is originally just 0, 0, 0, and let's say the weights are 1, 3, 5, 1. So if I do a pass over the array, and for each weight I can either choose to extend, I might need two best arrays, one for open bags and one for closed bags, but like for each value here I can choose to create another bag where the next weight is either extending the end of that bag or creating a new bag. So I wonder if I need to have two best arrays. So originally, if I have 0 bags and I have a weight of 1, then I can say I can put that 1 in the first bag, and the weight of that would be 2. The weight of that would be, I guess I have a best open and best closed. So the best open will become 1, and the best closed will become 2. because there's K, so for the first bag, only 1 is input into it, but it's still open. And then the next time I go 3, and I can close, I can see that if I do 3 as the best open, no, I can make 3 this as, I can close the bag at 3. I can close the K equals 1 bag at 3. So the best close of one bag would be 3. And the best closed, best open of 2 bags is 3. And the best close of 2 bags is, wait, I'm doing this wrong. Alright, let's think about it again. So first pass is 1, the best open is 1, the best close is 2. Because if I close the bag at 1, then that's going to double. And then the next pass is 3. 3 can go into the first bag and close it, and then the best close would then be 4. But before I do that, the best close of one bag is 2, then the best open 2 bags is going to be 2 plus 3, which is 5. And the best close for 2 bags is 2 plus 3, which is 2 plus 6, which is 8. So that's the best open for 2 and best close for 3, or open for 2 and close for 2. Now the best open for 1 is still 1, because I can't close something like that. Doesn't quite work, I don't think. Best open is 1, and the best closed for 1 is going to be 4. The issue is when I close something, it's going to affect the best open spot, because the best open spot will just be where the end is. The best open is going to be I wonder if I should think of K as some set of indices. So K, if there's K is 2, then that means that there's like 1 divider in your array. And if K is K is 2, that means there's 1 divider in your array. K is more than 2, or K is 5, and there's 4 dividers. Maybe this is binary search, actually. What if I just did it? What if I just found the maximum minimum using binary search rather than using dynamic programming? 10 to the 5th. Okay. Alright, I'm going to scratch this dynamic programming idea here. I'm going to do binary search. So let's say is possible for the maximum, or is max possible for a particular score. and if it's a maximum score, would that work? Can I, in one pass, determine if a maximum score is possible? It's not like I don't know if it is possible. You go through, like if I said, is 10 possible for the maximum score within this array? I go 1. I can't make that a single array because that'd be 2. No, I don't think maximum score is going to be possible. I don't think this is binary search. Yeah, if you do a pass, I don't think with one pass. Okay, so let's go back to dynamic programming. So how would this work? As you go through your weights, the best open is going to be inclusive of the total weights. Is it inclusive of total weights? So the best open would be the total including it being open. Yeah, okay. So let's say you start with 0, 0. The best close is going to be 0, 2, 0. And then the best open for one bag is still going to be, the best open for one bag is always going to be 1 here. Like, you can always need to have the first bag start with 1. Yeah. And then the best closed for 2, so when you get to 3, best open for that would be the close for 2, close for one bag plus the 3, so that'd be 5. And then the best close for 2 bags would be 2 plus 6, which is 8. And then when you get to 5, well, you could close the 1 with the 5 and get the best close to be 6. Oh, sorry, when you did the 3, the best close should be 1 plus 3, which is 4. And then when you do the 5, the best close would be 1 through 5, which is 6 for one bag. And then for best open for one bag is still 1. Best open for 2 bags is going to be closed for one bag. The best open for 2 bags is you take the open for the previous, for the best open for the previous one, close it, and open it with the next one and see if that's better. So you'll take the 1, close it with the 3 and get 4, add it with the 5 and get 9. So the best open for 2 bags is 9, and the best close for 2 bags would be, you can either take the best open for 2 bags and close it and get like 14, or you can get or you can do the best close for 2 bags and do the best close. Oh shoot. Okay, I need to do this again. Hopefully I get it right this time. Right. Array 1. Best open for 1 bag is 1. Best close for 1 bag is 2. And then when you have 3, best open for 1 bag is still 1. Best close for 2 bags is 2. Best open for 2 bags is going to be the closing of the first bag, which is 2, and then opening it with this 1, so it's going to be 2 plus 3, which is 5. And then the best close is closing that bag, so 5 plus 3 is 8. Okay. Now when you get to 5, I think best open for 1 is still the same. Best close for 1 could be closing 1 through 5. No, I did the 3 wrong. Shit. Okay. Okay, let's do it again. So what is the order of operations here? C1, and then you see 3. Best open for 1 is 1. Best close for 1. Best open for 1 is 1. Best open for 2 is going to be closing for 1, opening with 3, so you get 5. Okay. Best closed for 1 would be open for 1 to ending this with this 3, so it would be 5. Best closing for 2 would be opening for 2, which is 5, and then closing for 2, which is 8. Is that correct? No, it's not correct. Best closing for 1 would be opening for 1, closing 3, so it's 4. Best closing for 2 would be opening for 1, closing opening with 2, and then closing with this 3. So this would be 8. Is that correct? Does it seem right? Okay, so I go through the opens first. So open for 1. Now with the element 5. Open with 1. Still open with 1. Open with 2 should be closing with 1, opening with the 5, so it'd be 9. So 1 to 3, which is 4, and then opening with 5. And best closing is going to be opening with 1 and going to 5. So it should be 6. And then best close for 2. Best close for 2 should be best close for 1, which is 6. No. I need to do it in reverse order. Oh gosh. 0, 0, 0. Alright. What I need to do is I need to actually calculate what the optimal thing is. What I expect to happen, then I need to figure out what should occur to get. So value is 1, value is 3, and then value is 5. So the open when the value is 1 is going to be 0, 1, 0. the close for it should be 0, 2, 0. When it becomes 3, the open is going to be 0, 1, 0, or 0, 1, and then open with 1, close with 1, and then open with 3, so it'd be 5. Close would be 0. With one bag, it should be 1 and 3, so it'd be 4. And closing with both bags would be 2 and 6, so it'd be 8. If you have open for 5, so it'd be still 1. For 2 bags, it should be 1 through 3. So it's either, it has to be open 1, close at 3, and then open at 5. So it'd be 4 plus 5, which is 9. And then close, it needs to be 0. Closing, technically there should be another one here at this point. Actually, no, there's K's too. With one bag, it's 1 through 5, so it's 6. With 2 bags, it's going to be 1 through 3, which is 4 plus 5 doubled, so that'd be 14. Alright, and then lastly, v equals 5, v equals 1 again. Open with 1 bag is 1 still, open with 2 bags, it has to be going 1 through 5 as 1 bag, so it'd be 6 plus another 1, so it'd be 7. Huh. It's 7. But because 7 is not bigger than 9, then it should be still... Should it be still 7? So it'd be... Can't still be 7. Oh gosh, so you either... So... The best thing you can have where it's still open for 1 bag, for 2 bags, is 9. So it'd be 1 through 4, 5 open. And so you can't do 6 plus 1 is 7. So you still want 9 as the best. And then close would be 0, 0, 0. Huh. I got a bigger number than 10. Oh, it's because I need to actually include the last number. So so it's 0, so 0, 6, 14. Closing for 2 bags. But then I would use the 9 because I need to close on the last bag, on the last element, rather than closing on some previous element. Okay, I think that works. Okay, so I need So the way that, so what's the order of, what's the logic order here? It's going to be, can I determine, can I, I do need two arrays here. So best open and best closed. Open, close, close. Okay, so it's going to be for each value in your, say the value is going to be weights. Weight is going to be weights at this index. And for each k, so bag in range of k, the best open for this index, for this bag, is going to be, so it starts with 0. So I think this should probably be 1 to k plus 1. So the best open for the first bag, I might need to set the initialize the first bag to just have the first correct value. So, is that right? Because it really can't be anything besides the best open for the first bag be the first element. So best open for bag 1 is going to be the first weight. And the best open for, so I can't really do the first bag, so can I do the later bags? Maybe I should just start with the best close. For this bag is going to be best open is going to be the maximum of best open for this bag plus this current weight, or whatever is current there. Whatever currently there is best closed for one bag. And then the best open for this current bag, let's say this is bag 1,